Picture this. You're on an AD assessment and you've got admin access to a domain joined host. You run Bloodhound and you see that a Kerberos Delegation flag is enabled, and that one flag allows you to move laterally or completely compromise the domain. This is how powerful Kerberos Delegation can be, and it's important that you know the 3 types, what exploitation looks like, and how to properly remediate. To get started, we need to understand what's known as the double hop problem with Kerberos. So in this example, a user's workstation presents their ticket granting ticket to the domain controller. In exchange, they get a service ticket, which allows them to temporarily access the web server. When this user presents that ticket to the web server might need to retrieve information associated with their account by querying the backend database also on the network. The problem with this is that the database server won't accept a service ticket that was originally intended for the web server. So this leaves the web server with no way to authenticate on behalf of the user to the database. With the release of Windows Server 2000, Microsoft tried to give administrators a solution to this problem by allowing them to set a delegation flag on AD objects. So what this did was when a user tries to authenticate to a server with this delegation flag set, the domain controller will include a copy of their ticket granting ticket within the service ticket used to authenticate to that server. So that server can then extract that ticket granting ticket and just hold it in memory until they need to authenticate as you, when they can just pull that out of memory, get a new service ticket, and then forward that on to any host in the network. So I have some demos that I pre-recorded for all 3 of these delegation types. So for the first one, I set up this scenario where we have a compromised PHP app where we've uploaded a web shell. We use that web shell to get a reverse shell back to our host machine. And we use something like a potato attack to escalate our privileges. So now that we have admin on this machine, we can run Bloodhound to look at where this machine fits into the rest of the network. And Bloodhound will tell us pretty quickly that this machine has unconstrained delegation enabled. And what that means for us is that we can run Rubius or Mimikatz in order to check what ticket granting tickets have been stored in memory and steal them. And in this case, luckily for me, a domain administrator had signed in, so we can just steal their TGT and basically just compromise the network. But in other cases, this can just be another way for a lateral movement, depending on what users have authenticated to the server you compromised. So as you can see, I just grabbed that base64 encoded ticket, used a couple tools to get it into a format that I can use with the Impacket suite, and just run secrets dump. So obviously this had a pretty glaring security hole in its design, and in 2003, Microsoft came out with constrained delegation. And what this meant is that alongside the flag enabling delegation for the machine, it also allows administrators to define what specific systems it's allowed to delegate authentication to. So in the case of our app, for example, we would say that it can only delegate authentication to the database server because it really doesn't make sense for this application to delegate anywhere else. It also moved away from storing TGTs in memory and just allowed servers to request authentication for other users with these special new types of requests. So for this demo, we ran Bloodhound again. It told us that the machine has constrained delegation allowed to authenticate to the database server, or in this example, I used a file server. So in order to get that service ticket from the domain controller, we need the NTLM hash of the computer account, which we can get since we're admin on the machine, and we can run Mimikatz, for example. And then we can just request a service ticket using Impacket get st. And when we get the service ticket, it's easy from there. We can just authenticate to the file server and run secrets dump in the same way. And finally, in 2012, Microsoft came out with resource-based constrained delegation. And this flipped it from the flag being on the web server in our example to the flag being on the database server. So instead of an administrator defining what services the web server can delegate to, instead, the database server can just decide for themselves who is allowed to delegate authentication to them. This wasn't so much a security improvement as it was just a convenience improvement, and it actually changes the way we attack it in a pretty cool way. So in this last example, we're not so much looking for a delegation flag already existing on a host. We're more interested in generic write privileges on any computer object. Because if we can write to the computer object, we can control that resource-based delegation flag and enable it ourselves. Not only that, but we also create our own computer object and allow delegated authentication from our own fake computer object to that that resource that we have write access to. So this might make more sense seeing the demo. So we have generic write access over this file server. So first we can create our own computer object. In this case, I called it fake computer. And then we can write to the file server's attributes that this fake computer is allowed to delegate authentication to the file server. And once that's done, we can just ask the domain controller for a service ticket for any user using the credentials of that fake computer object. So this is what it looks like. And in this case, I ask for a service ticket as the administrator of the domain and then run secret stump on the file server. So hopefully that helps with understanding Kerberos delegation attacks, and also the next time you go to report on it, you have a better understanding of what it would look like to migrate to another form of delegation, be it from unconstrained to constrained. And in general, it's always just best to be able to explain these concepts when reporting on them.